Today we'll be talking about the importance of fracture mechanics and applications. My name is Xander Chithlin and this is my presentation. What is fracture mechanics? It is the study of microscopic cracks in all materials that lead to failure. These cracks are tiny spaces between grains of structures in metals that grow due to overuse and high stress. In fracture mechanics, we calculate and discover what happens to different materials under large amounts of stress. Usually, a small crack is the reason a part fails. It will become larger until it breaks, as the picture on the left shows. You can see where it began and then the waves of use until it finally completely broke. When a part breaks, it is usually caused by stress, but the metal goes through different sections. The first section is plastic deformation, which in a tensile test is when the metal stretches and necks. The next is ultimate material failure, which is when the part finally breaks. In fracture mechanics, there are three main types of applications, with the first one having two situations. The first application is called the thin plate application. The first situation is when the crack is on the side of the material. And the second situation is when the crack is in the center of the material. The difference between these is when the crack is in the middle of the material, it is 2C, while when the crack is on the side, the length is only 1C. In this application, the force is perpendicular to the crack. Therefore, when it pulls, the test is to see if the crack bends open or rips completely in half. The second application is the thick plate application. It usually occurs when a dent starts on the surface of the material, and it is when a high force is also pulled perpendicular from the crack, trying to rip the piece in two. The final application is the tensile test. It is when a cylinder or square bar of material is placed in between two clamps, and it is pulled with a high force. The test is to see when the material stretches and then necks, and eventually see when the material ultimately fails and cracks. The example that I have chosen is the thin plate application. In this example, the length of the center crack is 2C, and the width of the sample piece is 2W. The sigma is the gross section of tensile stress when a fail is supposed to occur. The Pmax is the ultimate force of an object without it failing. The Sy is the plastic deformation force. The Su is the strength of the object when it fails. The T is the thickness of the material, and the KIC is the acting stress, and that is when the fail is said to occur. In this example, you can see that Pmax is 16,970 pounds per square inch, which is the max force that has occurred on the material before a crack occurs. If you switch that into sigma with the equation that is written, you can see that it takes 56.6 KSI to create the crack in the material. which is smaller than the said KIC, which is 60 KSI, which means the part would break before it normally should. In fracture mechanics, it is important to test and calculate all applications precisely to ensure that objects made out of these materials can support their said weight, withstand being under large amounts of pressure for long amounts of time, so that they can protect humans and set safety precautions. It is also important to test all materials so that when used to fabricate real-world objects, mistakes such as these images on the right do not occur. In calculations, it is also important to factor natural forces such as wind, rain, hot, cold, erosion, and structural ground levels. Thank you for listening to my presentation about fracture mechanics.